Alright, so in the previous lesson we reviewed SOHCAHTOA, and SOHCAHTOA is actually can only be used when there is a right triangle. But what happens if we have a non-right triangle and we have to find the angles or the sides? Well, in that case we need to use the sine law. Okay? So here we have a triangle ABC. Notice that the corners of the triangles, the vertices, are labeled by capital letters, and the sides of the triangle are labeled by the small letter opposite of the vertices. So this is angle A, and opposite is side A. This is angle B, and opposite to angle B is side B. And this is angle C, and side C is opposite. So, whenever you're given an oblique triangle, a non-right angle triangle, so there's no right angles here, you label the sides and the lengths in terms of the vertices. So, the side of length little a is opposite to angle A, like we talked about earlier. The side of length B is opposite to angle B, and the side of length C, little c, is opposite to angle C. Now the sine law is a ratio between the sides and the angles. So side A over the sine of angle A equals side B over the sine of angle B, or equals side C over the sine of angle C. You can also put the angles on top and the sides on the bottom. It doesn't really matter as long as you are consistent. Now we'll get to this when we start doing some examples. So for now, this is the sine law. Okay? Okay, so let's look at this example here. We have triangle ABC. Two angles are given to us and one side. We need to calculate the length of C, little c, here in the triangle. Note that this is not a right triangle, so we cannot use SOHCAHTOA. So, can you use SOHCAHTOA? No. Why? Because it's not a right triangle. In order to use the sine law, we must know an angle and the opposite side of that angle. Do we know such a pair? Okay, well let's look here. We know this angle right here, 75, and we know the opposite side, 8. So yes, we do. Which pair? So if we look here, angle A and side A. What other piece of information is given to us? Well, we have angle C, which equals 35 degrees. What piece of information are we asked to find? We want to find side little c. State the sine law below. Okay, so remember, from above, the sine law is little a over sine of angle A equals B over sine of angle B equals little c over sine of angle C. Now, we're not going to use this whole law because we don't have all the pieces of information here. We only have 4 pieces of information. One of them is the piece of information that we're trying to find. So what do we have? We have little a, we have angle A, we're trying to find little c, so we have that, and we have angle C. So our sine law becomes A over sine A equals C over sine C. Now we substitute what we know and we solve. Okay, so let me just redraw the triangle down below. Okay, so this is kind of a recreation of the triangle above there. You can rewind back to look at the triangle if you don't believe me. So we have ACB, and we have angle A, angle C, side A, and we're trying to find side C here. Okay? So, remember the sine law uses the angle and its opposite side, and another angle and its opposite side. So going by what we wrote here for the sine law, little a is 8 over sine 75 equals little c over sine 35. And now to find little c, we just cross multiply. So the 8 and the sine 35 get multiplied, and we divide by sine 75. So c equals sine 35 times 8 divided by sine 75, which equals 4.75. Okay, let's look at this triangle. Again, ABC. We're given angle B, and now we're given two sides. Side little b and side little c. Okay, so is this a 90-degree triangle? Do you see any 90-degree angles in the triangle? The answer is no. So can we use SOHCAHTOA? Again, no. Why not? Because it's not a right triangle. In order to use the sine law, we must know an angle and its opposite side. Do we have such a pair? Well, we have angle B and the opposite side, little b. So, yes, we do have such a pair. What other piece of information do we know? Well, we know side little c. And what piece of information are we asked to find? We're asked to find angle A. So let's go back up to our triangle here. We have this angle in this side and this side that corresponds to angle C. So we could easily find angle C, but we're asked to find angle A. That's okay though, because we know that once we know angle C up here, all angles in a triangle have to add up to 180. So then we'll be able to find angle A. Therefore, our plan is to first find angle C. First find angle C, then use the property that all angles in a triangle add up to 180 to find angle A. So if we use the sine law, we have angle B and side B, and we need to find angle C, and we have side C. Two angles and their opposite sides. So the sine law becomes B over sine B equals C over sine C. Now we just plug the numbers in, and we get 12 over sine 30 is 10 over sine C. Now again, we can just cross multiply. We're trying to find this. So these two get multiplied, and we divide by 12. So sine 30 times 10, cross multiply, divided by 12 equals sine C. So if you do the math on your calculator, 0.4166 equals sine C. Now we're not interested in sine C, we're actually interested in angle C up here. Okay, so how do we go from sine C to angle C? Well, again, we have to do what we did in the previous lesson, the inverse sine. So inverse sine of 0.4166 equals C. Therefore, we get that 24.6 degrees is angle C, and therefore angle A is 180 minus the other two angles, which gives us 125.4 degrees. Alright, so now let's move on to a more complicated problem. One that you will find throughout this textbook. I've given you the diagram here. Sometimes you will be expected to draw the diagram. Anyways, I'll just give you a second to read the question. So pause the video and read the question. So just one thing, when you're reading this, right here, the directions, this is read as 30 degrees west of north. So if we look down here, what does that mean? Well, we know we have north, south, east, west. So we're talking about 30 degrees west of north. So straight north is up straight, so we're not going to go straight, we're actually going 30 degrees west. Okay, so in there is 30 degrees. And when we're saying N50E, what that means is 50 degrees east of north. So again, straight north is in the upward direction. So we want to go about 50 degrees east. So that would be 50 degrees east of north. Okay? So just keep that in mind when you're reading the directions. So our sailor is at lighthouse B over here. So we'll draw a set of coordinates there, so that's north. And he needs to get to lighthouse, and he needs to get to lighthouse A over here. Now notice that this line is not perpendicular, but this line right here and this line are parallel. Okay, so that means that we've created an angle right in here. Okay, so let's redraw the triangle over here. Okay, it's just slightly complicated, this diagram, and we have A, B, and C. This angle in here is 80 degrees, and that comes from the fact that the 30 and the 50 have combined to make 80. Okay, we know that this line right here is 12. We know that AC is 9. So we do have enough to find out what angle B is here by using the sine law, because we have an angle and its opposite side and another angle and its opposite side. So let's start by writing out the sine law. C over sine C equals B over sine B. So now we're going to fill in the variables with the numbers. So 12 over sine 80 equals 9 over sine B, and now we're going to we need to find sine B, so we're going to cross multiply here and then divide. So sine 80 times 9 divided by 12 equals sine B. So 0.7386 equals sine B. Now don't take my word for it. Pause the video, plug it into your calculator, make sure you're getting the same numbers that I'm getting here, okay? So now to get angle B is equal to inverse sine 0.7386, which is equal to, what happened there? Which is equal to 48 degrees. But we're not quite finished yet. Okay, we found angle B, so let's go back to the picture and fill it in. So this whole angle right here is 48 degrees. Okay? But this little angle in here is 180 minus 90 minus 50. So that little angle in there is 40. And the little angle right there is 8 degrees. Okay, so let me just redraw angle B for you guys here. So that's angle B right there. We have a line going straight north, okay, and we have the east and west line also right there. That's west and that's east. Now the east and west line is splitting the whole angle B into two angles, one that is 40 and one that is 8, and the total angle is 48. Now we know that the east and west line right here and the north and south line make a 90-degree angle, right? But this little angle right here is 8. So that means here, whatever is left over is 82 degrees. And that's in the direction the captain has to sail. So he has to sail 82 degrees west of north.